In this video, we're going to talk about how to find the equation of a line under different circumstances. So we're going to talk about when you're given the gradient and the intercept on the y-axis. We're going to talk about when you're given the gradient and 1 point on your line. We're going to talk about when you're given 2 points on your line. We're going to also talk about when you're given a parallel line or a perpendicular line to your line and probably a point on your line. So let's quickly jump into the video. Okay, so before you jump into solving this kind of problems, there's something I really want you to know. So this is the default slope-intercept form for the equation of a line. Now, this M represents the C here represents the y-intercept. So let's say example A. Actually, if I'm to find the equation of a line for a gradient of 5 and y-intercept of 3, I'll simply be plugging those values inside this equation. So my equation of a line will be simply y is equal to, my gradient is 5, so I have 5x plus my intercept is 3, so that's 3. So that's all. And then for the B part, still be the same thing. You can pause the video and try to solve that one yourself. So for the B part, I'll have y is equal to, my gradient is minus 2x plus my intercept is minus 1. So that's minus 1 here. So this becomes y, this implies that y is equal to minus 2x minus 1. So this is my equation of a line for the second one. Now, you can also pause the video and try to solve C by yourself. So for the C portion, if we take a closer look, we have the gradient on, but the intercept was not clearly stated. Okay, but we are given a point. Now, if we're given a point, and this point, you should know that these two values are represented as x, y. So the first value is often given as the x value, and the second value is given as the y value. So to find, this means that our y-intercept, if you draw a graph, our y-intercept, the intercept on the y-axis happens when x is equal to 0, right? So this means that 1 here is our y-intercept. So that means our equation of a line is equal to, our gradient is giving us 1 over 3. So this is 1 over 3 times x. So this is basically x over 3 plus our intercept is 1. So that's the equation of our line for C. Now for D, our intercept is passing through the origin. So that means our y-intercept is 0. So that means our gradient y is equal to 3x plus 0. Or we can simply just say y is equal to 3x. Okay, so for the second set of problems, when you are given the gradient and a point on the line. So for A, we know that our gradient is 3 and it is passing through this point on the line. So if you write out our slope-intercept equation of a line, which is y is equal to mx plus c. Now we know our y from the coordinates we're given here is 1, 4. So our x is this, which is 1. Our y is this. We know our y, we know our m, we know our x, but we do not know our c. So we can actually find c and plug it into this equation to give us our equation of a line. So to do that, I'll be using c is equal to y minus mx to get my value of c. So that c is equal to, the value of y is 4 minus m is 3 times x, which is 1. So we have c is equal to 4 minus 3 times 1 is 3. 4 minus 3 is equal to 1. So our equation of a line for this can be written as y is equal to, our gradient is 3, and then write our x plus our c value, which is equal to 1. So there's also an alternative form of quickly going straight to your answer. So you can quickly write. So when you're given a slope and an intercept, you can quickly use this equation to solve. So basically the point you have is this point, and then you can substitute your value for y and x. Now this is called the slope point form of equation of a line. Now remember, we said this is the slope intercept form for equation of a line. This is just another way to quickly help you solve problems when you're given the gradient and a point on the line. So for the second example, we have our gradient or slope to be -2 and our point to be 2, 0. So you can pause the video and quickly try to solve this one yourself. Okay, so our equation of a line would be y minus y1 is equal to m open bracket x minus x1. So we have y minus y1 is, and this is equal to m is -2, open bracket x is x, and then x1 is 2, right? So we have y is equal to -2 times x is -2, x -2 times -2 is +4. And leave your equation as y is equal to -2x plus 4. So that's how to find the equation of a line when you are given the gradient and a point on the line. There are several ways to solve this kind of problems, but I prefer getting my gradient first and then using a point on the line to solve the problem. So to start off, I need to find my gradient from these 2 points. So my first point is 3, 4, and second point is 5, 4. So this is my first point, and then this is my second point. So to find the gradient, I would use this simple formula: y2 minus y1 divided by x2 minus x1. So that y2 is 4, and then y1 is -4. Okay, so x2 is 5, and is 3. So this is equal to 0 over 1, 0 over 2, which is equal to 0. So the gradient is equal to 0. So the next step is to use what we call the slope point form to find our equation of a line. Now remember the slope point form, like I said it before. Okay, so from the slope point form, you can pick any point here and use it to substitute into this equation. You should get the same equation of line. So from there we can have y minus y1. Let's pick this point. Okay, so y1 here is 4, and then this is equal to m is 0 from brackets, x minus x1 is 3. So everything here becomes 0. So we know that equation of a line is y equals to 4 in this case. So for the next example, you can pause the video and solve it by yourself. So I'm simply going to be doing the same thing. I'm going to be saying they have 0, 4 and a 4, 0. So this is going to be my first point, and then this is going to be my second point. So for my slope, I'll be saying m is equal to y2 here is 0 minus y1 is 2 divided by x2 is 4 minus x1 is 0. So ultimately I have -2 over 4. So this is equal to -1 over 2. Okay, so from here now I can use the slope point form to get my equation of line. I could pick any point I want. So let me pick point 1. Okay, so I have y minus y1 is 2, and this is equal to, I have minus half, and then open bracket x minus x1 is 0. So if I simplify this further, I should be getting y minus 2 is equal to minus x over 2. So moving this one over to this side, y is equal to minus x over 2 plus 2. There are some facts I would like to establish before we get into this. So when you have this form of equation of a line ax plus by plus c or something like that is equal to 0, this is called the general equation of a line. And it can still be rewritten in the y is equal to mx plus c form. Okay, so naturally I like putting it in this state before starting to solve my problems. Another thing I would like to state is that when you have the slope, when you have two parallel lines, the slope of the first line is equal to the slope of the second line for parallel lines. And for the second point, if you have two perpendicular lines, slope of the first line times slope of the second line is equal to minus 1. So this is for perpendicular lines. Okay, so with all this now, let's quickly jump into the problem solving. So for problem 1, we have a point on our line. Find the equation of a line which passes through this point and is perpendicular to this line. Okay, so we have a point on our line. So the point is minus 2, 1. And then we have a perpendicular line. So I want to switch this perpendicular line to the slope-intercept form. So that will be saying 4 minus 2y plus 1 equals 0. So switching this into the slope-intercept form, I'll be saying minus 2y is equal to moving x and constant over to this side. This is minus 4x minus 1. So this becomes y is equal to minus 4x and then minus 2 minus 1 over minus 2. So I have my y to be equal to 2x plus 1 over 2. Okay. So this is my equation of a line in the slope-intercept form. So I now know my slope of my perpendicular line to my line that I'm looking for to be m is equal to 2. Okay. So the slope of my perpendicular line is 2. Now I'm looking for the slope of my line. So let's call it ML. This is the line that I'm looking for. The slope of the line that I'm looking for. The slope of the line that I'm looking for, let's call it ML. So that slope is unknown. Now I know for a fact that M1 times the M of my line is equal to minus 1. So this simply implies that M of my line, the slope of my line, is minus 1 divided by M1, which is minus 1 over 2. So from here, I have the slope of my line and I have a point on my line. Now remember the slope point form that we used earlier. So the slope point form for equation of a line is y minus y1 is equal to m open bracket x minus x1. So the point is this point. So this is our x value and these are our x1 value and our y1 value. So this can be written as y is equal minus our y1 there is 1, and then this is equal to m is minus 1 over 2 open bracket x minus x1 is minus 2. So let's clean up a bit of space. Y minus 1 is equal to minus 1 over 2x, and then minus this minus times minus is plus, then minus 1 over 2 times 2 is minus 1. Okay, So from here, I can move the constant over to the other side. So that this becomes y is equal to minus 1 going onto this side cancels minus 1. So I have minus 1 over 2x. So the equation of a line this that passes through this point and perpendicular to this line is this is equal to this. So let's quickly go to example 2. So for example 2, I'd like you to pause the video and try to solve that one yourself. Okay, so we've gotten what we've gotten. So we know that if we switch, the points we are working with is still the same point, which is minus 2, 1. And then the equation of the line that we're working with is y is equal to 2x plus 1 over 2. Okay, so now we know that our slope for our parallel line, in this case, the second case is a parallel line. So the slope for a parallel line is equal to 2. So the slope of the line that we are looking for is, let's call it ML, like we did before, is equal to MY. So this is because both lines are parallel, like I said before. So that means the slope of the old line, ML, is equal to 2. Okay, so if ML equals to 2, we can use our slope point intercept form to get our equation of the line. So our slope point intercept form is y minus y1 is equal to m over bracket x minus x1. So y is minus y1 is 1, and then this is equal to 2 open bracket x minus, then our x1 is minus 2. Okay, so this is now y minus 1 is equal to 2. Expanding this bracket here, we have x plus 2. So we have y minus 1 is equal to 2x plus 4. So we have y is equal to minus 1 going over to this side becomes 2x plus 4 plus 1. So y is equal to 2x plus 5. I hope that after watching this video, you've gotten a solid idea about how to find equation of a line for different cases. Thanks for watching the video. If you liked it, leave a thumbs up, subscribe to the channel, and leave a comment. Thanks for watching again.